In this video, I'm going to be describing parts of an isosceles triangle and also properties of an isosceles triangle that will help us solve for some unknown measures. So let's start with the parts of an isosceles triangle. The two congruent sides on an isosceles triangle are called the legs. Opposite from those or across from those are called the base angles. Attached to the base angles or the non-congruent side is called the base. And opposite from that, or the non-congruent angles, is called the vertex angle. There's a few more parts. An isosceles triangle can have an altitude drawn. And an altitude in an isosceles triangle is a little bit more special than other altitudes in that it bisects the base and it bisects the vertex angle. So an altitude must come from a vertex and be perpendicular to its opposite side. In addition to that, an altitude in an isosceles triangle bisects the base and bisects the vertex angle. So if we wanted to name the pieces of this isosceles triangle, the two congruent sides are the legs, so side or segment AB and segment AC. The other side, the non-congruent side, side BC or segment BC, is the base. Be careful though, if this triangle gets rotated, the base may not always be positioned at the bottom. It is always the non-congruent side. So if this triangle got spun around a little bit, the two congruent sides would always be the legs and the base would always be the other side. Attached to the base, or the two congruent angles, are called the base angles, so angle B and angle C. They're also always across from or opposite the legs. So if two angles are congruent, the side lengths across from them must also be the same length. So base angles are always across from the legs. The vertex angle is always the non-congruent angle. So angle A up there is the vertex angle. And then this segment here that is bisecting the base and the vertex angle and is perpendicular is the altitude, so segment AD. So the properties of an isosceles triangle that will help us solve for some unknown measures are that the legs are always congruent. We can set them equal to each other. The base angles are always congruent, and we can set those equal to each other. And the altitude has three special things about it. It's perpendicular to the base, it's bisecting the base, and it's also bisecting that vertex angle. Most of what we'll focus on, though, are the first two properties. So let's practice using those properties. Given an isosceles triangle, let's find the measure of the missing side length over here. Well, this missing side length is a leg, and these two legs are congruent or the same measurement, so this length must be 9. Let's do the same thing, but with a little bit of algebra. So let's find the length of the legs here. Because they're the legs, they're congruent or they're equal to each other. So we can solve for x by setting these two expressions equal to each other and solving for x. To solve for x, I could subtract x from both sides and add 9 to both sides, and I would get my solution. X is 14. So now that I know what x is, I can plug it back into either expression because they're equal, and we could also check our work that way. I'm going to plug it into the right one because that seems a little bit easier. X plus 5 turns into 14 plus 5, which is 19. I can check my work over here. If I plug in 14 over here, 2 times 14 is 28, and 28 minus 9 is also 19. So we correctly solved for x there. This next example, we're going to use the properties of the angles. Since we're given the vertex angle of 40 degrees, that means that the other two angles are the base angles. They're across from the legs. They're going to be equal. So whatever measurement this angle is the exact same measurement. So if this angle measures x, this must also be x. And we know that all three angles inside a triangle add up to 180. So I can say that x plus 40 equals 180. Combine my like terms, so I have 2x plus 40 equals 180. Subtract 40 from both sides and divide by 2. And we get our solution for x is 70, and that's the measurement of that angle. That would also be the measurement of the other base angle because they're congruent. Here's another example, a little bit more algebra involved here. This time we're going to find the value of y, so what's the measurement of that angle? And we're going to find the measurement of b, so once we solve for x, we're going to plug that back in and find this measurement. Well, y is a base angle. It's across from a leg. So if one of the base angles is 52 degrees, the other base angle is congruent. It must also be 52 degrees because these base angles are equal or congruent. So since we know what that is, we can add 52 plus 52 and combine that with 14x plus 6. And we know that all three angles are going to add up to 180, so set it equal to 180. Combining any like terms, 52, 52, and 6. That's 104 plus 6, which is 110. Subtract 110 from both sides, and then divide by 14. And we get our solution for x is 5. So now that we know that x is 5, I can find the measurement of angle B by plugging 5 and substituting it back in for x. So 14 times 5 plus 6. 14 times 5 is the same as 10 times 5 plus 4 times 5. So 10 times 5 is 50. 4 times 5 is 20. Add those together, we get 70. And 70 plus 6 is 76. So the measurement of angle B is 76 degrees. We could then check our work, add up all our angles. We got 52 degrees here, 52 degrees here, and we said this was 76 degrees. So 52 and 52 is 104, and 104 plus 76 indeed adds up to 180. One last example. Let's do a bit of a challenge here. We're only given the measurement of this angle right here, and we're asked for the measurement of this angle way over here. We're going to use the properties of an isosceles triangle here, and a bit of other properties as well. So 120 plus this angle on the other side is a linear pair. They're going to add up to 180. So this angle must be 60 degrees. That's the vertex angle of this isosceles triangle. So I know that these two are going to be the base angles. They're going to be across from those legs. So I know 60 degrees inside this triangle so far. That means 120 degrees must be left over. If I divide that equally into two angles, I get 60. So each of these angles are 60. In fact, all three angles here are 60 degrees. This is an equilateral triangle, not just an isosceles triangle. So this measurement is 60 degrees right here. Vertical from that is a congruent angle. So this angle is 60 degrees. And that's a base angle in this isosceles triangle. This angle over here is another base angle. So it must be equal to that angle. So if that's 60, this must also be 60. And then this angle right here is vertical from there, so it must be congruent. So x is 60 degrees. So there's a bit of practice using isosceles triangle properties and knowing what the pieces or parts of an isosceles triangle are.